Somehow, I too am doing the heat death of the universe, so buckle up. Awesome presentation. Alright, so what is the heat death? So basically, when this theory, when the universe has reached a state of maximum entropy. So all available energy has basically moved from like high state into all of its available low states. So essentially it's thermodynamic equilibrium. So what does that mean? So in terms of heat, if there's no heat flow, there's no work can be achieved. So it was also like kind of in the theory itself that once heat flow was gone, the other types of like mechanical and electrical energy would follow, and that would all reach a equilibrium state. So in terms of the universe, no work can be extracted from so essentially that's the end of the universe. So who came up with this and why is he bumming me out? So it's Baron Kelvin. He's from the 1850s. He came up with this. He's also known as the Lord Kelvin. Took the theory of heat and mechanical energy laws of nature with the first two laws of Fermat, and he expanded it, the application of a larger process on a universal scale, and really just tried to think ahead of the day-to-day of what's happening, and if we do all of our reactions basically adhere to entropy, what happens if we reach its maximum. So, entropy. Second law of thermodynamics, the amount of entropy in a system must always increase. So, entropy quantifies as order. So, higher the entropy, more disorder the system has. So, instead of how Kate went into the very nit and grit of how entropy, I'm just going to basically lay it out like this. I'm looking at it as disorder because it's actually a pretty difficult subject to kind of try to describe as you have all witnessed. So let's do an example. So right there, that's gas burning. So a chemical reaction will only occur if the results increase in entropy. So if we burn gas, what's happening? So the liquid that we're starting with contains a long chain of atoms. And after we burn it, heat's created. We'll also have water vapor, carbon dioxide. So these are two small gaseous molecules which start in a pretty steady, like more orderly state. But after it's burned, the amount of disorder in the system has increased, and we also have heat. So what does that really tell us? Any reaction that takes place will result in either, like I just said, products becoming less ordered, and heat being given off. So basically, a lot of what revolves around this heat death is that sometime in the future, all these reactions will just be done. Any reaction that could have happened has already happened. No more reactions can happen. So all that is left is basically electromagnetic radiation and some fundamental particles. And so this is the weird part. In a reaction that happens up to this point now, after entropy has reached its maximum, entropy will actually decrease, which as we know is physically impossible. But this is this theoretical state where it seems almost impossible, and it's really hard for us to kind of wrap our heads around. So, I'm calling it timeline of our demise. What's happening? Today's life. Graduation. We're going to enjoy our summers, so that you're going to get to have your summer, and then heat death the entire universe. In about 10 to the 103 years from now, so we can take a breather. But what does this mean for humanity? Guys, we got to really work here. We're going to have a bit of increased anxiety from this. This is really stressful. Possible spike in interest in thermo, which probably will spike right back down because all of you hate it, unfortunately. Solar is probably over there just, can you all please be interested for a little bit? But, and then, I don't know, you might get religious. Find yourself some Jesus. But yeah, it's such a, it's a joke, but it's such a ridiculous topic, and very theoretical that it's so far away, it's really hard to actually wrap your head around it, but it is cool. There's a bunch of different theories out there. That one that's kind of the opposite is what they're calling kind of a cold death universe. Actually, which was it? It's because of so much expansion is happening, because like physicists say our universe is always expanding, that it's actually going to drop to freezing temperatures, and we're basically just going to like freeze ourselves out. And one keynote that I want to say about this is that because the heat death of the universe, it's solely like reliant on entropy and that equilibrium state, doesn't mean that it's going to be a high absolute temperature. We're not going to just like be on like a fireball and all the living Earth is just like living life is going to be screaming. It's just going to be a slow teeter out to, I guess, non-existence for everything. As happy as this subject is. So, any questions?